300 centimeters cubed of a 0.1 mole per dm cubed solution of sulfuric acid is added to 200 cm cubed of a 0.5 mole per dm cubed solution of NaOH at 25 degrees Celsius. The equation for the reaction that takes place is, so H2SO4 plus 2 NaOH gives us Na2SO4 plus 2H2O. Now the question that's being asked is to calculate the pH of the solution. So what is the resulting pH? Now, you would be tempted to say that sulfuric acid is a strong acid and NaOH is a strong base, so the salt will be a neutral salt. However, we need to be careful because we need to check if there's anything in excess. So first, let's go ahead and calculate the number of moles of each thing. So we'll start with the H2SO4. So H2SO4. The concentration was 0.1. The volume was 0.3. And so the number of moles is going to be C times V, which is 0.1 times 0.3. And that's 0.03 moles of H2SO4. Now repeat for NaOH. So NaOH, we've been given a concentration of 0.5, a volume of 0.2, and then number of moles is CV, 0.5 times 0.2, and that gives us 0.1 moles of NaOH. Now, if we look at the ratio of which the acid and the base are reacting, we can figure out what's in excess. So the H2SO4 to the NaOH. So the ratio is 1 to 2, and we get that from the reaction. We have 0.03 moles of the H2SO4. That means we only need 0.06 moles of the NaOH. That's the amount that we need. But we have 0.1. So that means we have more than we need. And so the NaOH is going to be in excess. So the NaOH is going to be in excess, which means that our resulting pH should be greater than 7. And that's because NaOH is a base. So now, next week, we should be working out how much of NaOH is left over. So the NaOH that's in excess, so NaOH left over is going to be how much we have. So we have 0.1 minus how much we need 0.06. And so the amount of NaOH that's going to be left over is 0.04 moles of NaOH. Now, this is going to be what's going to be affecting our pH. So let's take a look at what happens with the NaOH that's in excess now. So the NaOH that's in excess is going to dissociate. It's going to break up into Na plus ions and OH minus ions. Now, we know the number of moles of this. This is 0.04. That means the OH will be also 0.04 moles. And this OH is sitting now in a container that has a volume of 300 cm cubed plus the 200 cm cubed. And so it's sitting in a volume of 500 cm cubed. And so we can work out the concentration of the OH minus. So the concentration of this OH minus is going to be the number of moles, which is 0.04, divided by the volume, which is 0.5, and that's equal to 0.08 moles per dm cubed of my OH minus ion. Now, since they tell us that this is taking place at 25 degrees, we can use the autoionization of water to calculate the concentration of H3O plus. So we can then say that Kw is equal to the concentration of H3O plus times the concentration of OH minus. Since we want the concentration of H3O plus, we can say that Kw, which is 1 times 10 to the negative 14, divided by the concentration of my OH minus, which is 0,08, that's equal to the concentration of the H3O plus. This then works out to 1,25 times 10 to the negative 13 moles per dm cubed, and that's the concentration of H3O plus. And then the last step is work out the pH. So pH is equal to minus log of 1,25 times 10 to the minus 13, and that gives us an answer of 12,9.